Hello, everyone.
Yes, ma'am.
Yes, ma'am.
Good evening, ma'am.
Yes, good evening. So, this is your week 5 open session. So,
Yes,
in
ma'am.
today's session, we will discuss about the basic principle of counting, addition and multiplication rule of counting, and permutation, and
Combination.
about factorial summary. And
Ma'am,
combination, we will study in week 6. Yes.
Okay, ma'am.
ma'am, I had a doubt in the week 4 graded assignment.
So, graded assignment solution will be uploaded so that you can check.
Now, can you explain me because
Okay, we can discuss in the doubt session, not in this session.
okay,
Yesterday already discussed.
Good evening, sir.
Okay, so now I am presenting my screen.
Okay.
Okay, ma'am.
Good evening, ma'am.
Ma'am, excuse me.
Hmm.
I have doubt regarding this week 4 practice assignment, ma'am.
Week 4
Not,
doubt session is already
it's
done.
not
So
like
Ma'am, it's
it's a
recorded,
question
ma'am.
doubt. It's like the practice section ENQ1. What is that? I want to just
sorry, practice.
practice assignment. In that we have ENQ.
So ENQ is basically you have a set of options and you have to select the option from those for each different question.
No, ma'am. They have given that option to write a code and submit, upload a PDF or document.
Okay, we can discuss it in the next session, or you can ask it in the TA session.
Excuse me, ma'am. Ma'am, I have a
Okay.
doubt regarding week 5.
So let
Ma'am,
me
it's
first.
necessary. Ma'am, it's necessary to attend week 5 classes.
No class is compulsory. It's your choice you want to join or not. It's for your help only. If you join the class, you will get the clarity about the topics.
Okay.
This is
Ma'am,
the doubt
ma'am,
also.
it's necessary to complete a week 5 assignment because a qualifier exam is coming.
So GA you have to submit before the deadline itself.
So if I skip something happen in my full what do it is called?
You can check the eligibility in the grading document.
Okay.
According to that, you can decide. Okay.
Okay. Thank you, ma'am.
Okay. Now, should I start the week 5 concepts?
Yes, ma'am.
Yes, ma'am. Okay. So the very first thing in week 5 is the basic principle of counting. So in all the upcoming 4 weeks, week 5, 6, 7, and 8. So in week 5 and 6, you will see the concepts of permutation and combination, the principle of counting and the factorial, these things. And in week 7 and 8, you will study about the probability.
Ma'am, are you talking about maths or statistics?
This is statistics session.
So, ma'am, in this
Permutation,
session, you will give one shot of week
statistics.
5.
Yes, in this we'll discuss the topic of week 5.
Okay, ma'am.
Okay.
I have doubt in week 5 activity question.
So that we'll take in the doubt session. Okay. Let me first discuss the topics and then we can take the doubts.
Yes. Yes, ma'am.
So that we can discuss in the doubt session. Today we will take the summary. Okay.
Okay, ma'am.
Okay. So yeah. So week 5 to 8 we will study the permutation combination probability. So in week 7 and 8 you will study about the probability. And for those concepts, you should know the all the concepts of week 5 and 6. Okay, so you should know the permutation and combination for studying the probability. Okay, so suppose you went to a shop and you got a gift card, and in that gift card you have the options of 4 shirts, and 3 pants. Okay. And you can select either one shirt or one pant.
Yes, ma'am.
So in how many ways you can select it? So we have
12.
So we have 4 shirts and 3 pants in total. And out of these 4 shirts and 3 pants, you have to select one thing, either one shirt or one pant.
Mm.
Okay. So in how many ways can you do it?
7.
So how did you get the 7? You are adding these two, right? 4 plus 3.
3, 7.
Okay. So you have to select, okay, either a shirt or a pant. So you can do this thing in 7 ways. So this how we have got this 7. So this is actually our addition rule of counting. Okay. So what addition rule of counting says is,
And you told to select one shirt and one pant together in how many ways?
no, only one thing, either a shirt or a pant. Out of all the shirts and pants, you have to select one thing only. It can be a shirt or it can be a pant. Okay. So now the addition rule of counting comes. So according to this rule, so if an action A can occur in N1 different ways, okay? So if there is an action or whatever you want to call it, so if an action A can occur in N1 different ways, okay? N1 different ways. And there is another action. So action B okay, another action B can occur in N2 different ways. Okay, then we have to say that the total number of occurrence of action A or B. Okay, so here we have A or B. So that can be done in N1 plus N2 ways. Okay, so you need to be careful about this thing. Okay, so you have two different actions A and B. So for A you have N1 different options, and for B you have N2 different options. Okay, so if you are selecting one thing only, so we can say that action A or B, so that can be done in N1 plus N2 different ways.
Ma'am, one doubt, ma'am.
If
Hmm.
I have
In this
four,
case, you just said that choosing only one option, it takes 7 ways. But if a condition was given that choosing two things, but it can be in any form, means we can do, it comes in various number of ways, ma'am. Choosing first two pants, then another two pants, then in between second and third pant, first and fourth one, then one first pant and second shirt, like that. Various more than 7 options are coming, ma'am. For that,
Yeah, just wait for it. I am coming to that point only. So this is the addition rule. So I am telling this thing according to this condition. Okay. Next we have the multiplication rule. There we do that thing. If you have to select one shirt or and one pant, you have to select two things at a time. Then we do that thing. Okay.
if
So
we consider 4 shirts in A and
yes.
3 pants in B,
Yes.
Then
Okay. So that's how it is
you are right
coming.
here, A or B. Then we have only 4 or 3 option way.
No. You are taking it wrong. So you have 4 shirts and 3 pants, right? In total, in a bucket, these clothes are there. Okay. You have to randomly select one. So total options are 7, right?
Yes.
Out of the 7 piece of clothes, you are selecting one, right? So you have 4
Yeah.
plus 3 equals to 7 options.
Yeah, ma'am.
It can be a shirt also, or it can be a pant also. Okay, now next condition is if you have to select one shirt, okay, one shirt and one pant. Okay, now this is your condition. Then now you have to select shirt and a pant. Okay,
12 ways.
leave it. So again, come to the multiplication rule. Okay, so next is the multiplication rule of counting. So according to it, again, if you have action A and action B, so action A you can do in n1 different ways, and action B can be done in n2 different ways. But now instead of A or B, we have A and B. Okay, so in an action A can occur in n1 different ways. Okay, and another action B can occur in n2 different ways. Okay, then the total number of occurrences of the action A and B together. So this will be n1
12
multiplied by n2.
and 2.
Okay, so in that case, it will be 4 into 3, which is 12. Okay, now the difference is that in the first part, we were taking only one thing. Okay, but here we are taking both the actions together. So we will be having 12 options. Okay, 4 into 3. Okay, similarly, if you have, so this is for 2 actions, suppose you have two things only, A or B or shirt or pant. Now, if you have more number of things, A, B, C, and D, so what do you have to do? In the multiplication rule, you have to multiply those things. So here we have n1, n2. In that case, we can have n1 into n2 multiplied by n3 multiplied by n4 and so on. Okay, depends on the number of actions you have. Okay, so now let's take an example of it. So suppose you have to create a 6-digit alphanumeric password. Okay, and what is the condition for creating this password is, so the password should have first two letters, okay, followed by 4 numbers. Okay, so this is the condition for creating the password. So we have six places, you can say. So in the first two place, there should be a letter. So we
Yes.
can say the alphabet.
Ma'am, is the option answer is 67 lakh 60,000 is the number of false possibles?
That I don't know. That we will solve and we will get to know. Okay, what is? I don't mug up the answer, so
No,
I
no,
can't
not mug
say.
upping, ma'am. I'm just calculating because first
Yes,
two
yes. After
alphabets.
calculating, we can see.
Yes, ma'am.
Okay, so in the first two places, we have to put the letters or the alphabets. In the last 4 places, we have to fill the digits, numbers. Okay. So now you can see. So how many number of ways we will have for the first two? If the repetition is not allowed. So first we will take the case. Okay, so first we will
Ma'am,
take
repetition is not allowed.
So there can be two cases. Repetition is allowed and repetition is not allowed. Okay. So if the repetition is allowed.
Excuse me, ma'am. Just one conceptual doubt means if in the question means certain questions we are asked about the number of selections of a particular things, then we will do the permutation or the combination.
It depends on you have to arrange the things or not. Selection we do in both the things. In combination also you select the things, and in permutation also you have to select the things. If you have to arrange it also, then you use permutation. And if you are not worrying about the arrangement, then you use combination.
I mean, suppose in this question only you said that first two letters should contain an alphabet. Means suppose out of the 26 alphabets, we are asked that in how many ways selection of the alphabets can be done. For example, A, B, and B. That will not matter, but it is asked. Nothing is mentioned, but it is asked that number of selections of alphabet. Then we will do the permutation or the combination.
You can simply do it by multiplying the values. You can simply use the multiplication rule or addition rule.
Means the multiplication rule is giving the permutation only because the order is constant, and because of that we are multiplying.
So in permutation and combination, we have to see whether the objects are distinct or not. Okay, just solve this question and then we will discuss about the permutation and combination also. So you can see in the first two places, we have to fill the alphabet and repetition is allowed. Okay. So what we have to do, how many number of choices we have here for the first
26.
place? 26. And for the second place?
26.
Again 26.
No,
If the repetition is allowed.
Yes, ma'am.
Okay. And then we have to fill the digits. So total we have 10 digits, right? 0 to 9.
Yes, ma'am.
So if repetition is allowed for all the 4 places, we have
We
10
have 10
options.
choices.
Okay. We have 10 choices.
Yes.
Now you can match
Ma'am.
with your answer, whatever is coming. Okay.
Yes. Yes.
And now the next one is that,
67 lakh.
yeah, it might be correct. You can check. So next one is that if repetition is not allowed.
Not allowed.
Okay. So if repetition is not allowed, then for the first place, you will have 26th option.
Yes, ma'am.
And then for the second place, we will have
We have 25.
25.
Repeat it again.
Yeah, just 1 minute. Let me complete it and then.
Above repetition is allowed.
In the second part, repetition is not allowed.
Ma'am, I asked that before repetition is allowed. You can clear my doubt.
Yeah, in the first part, we were taking that a repetition is allowed. Then what's the doubt?
Ma'am, can you explain? Matlab,
Okay,
your
see,
voice is crackle.
my voice is cracking for everyone.
No, ma'am.
Yes,
It's
No,
clear.
ma'am. It's clear.
ma'am,
No, madam.
from
No,
my
no, no,
side.
no.
From my side.
No, ma'am.
Okay, fine. Okay, see, for the first two places, so according to this condition, you can see password should have first two letters followed by the four numbers. Okay. So in the first two places, you have to fill a alphabet. So how many
Yes, ma'am.
letters you have in alphabet? You have 26 letters, right?
26. Yes, ma'am.
Okay. So for the first two places, if the repetition is allowed, you have 26 and 26 options,
Yes, ma'am. Understood.
right? And then for the last four places, you have to fill the numbers. So you have 10 choices for each place if the repetition is allowed. Okay. Now the second case, if the repetition is not allowed, so at this place, we will be having 26 options. Then you will have 25 options, right? And then for
Yes,
number, you will have 10
10,
options, then 9,
then 9, then 8,
then
8,
8, and then
then
7.
7.
okay. So this is how we can do this type of questions.
Excuse me, ma'am.
Hmm.
Ma'am, why are you actually asked that? Means can I just can you just go to the week 5 EMQ assignment? I will not ask the answer, but I am not able to interpret a type of question, so I have to just ask that.
I
Means,
have already told that we will discuss the question after the summary session or in the doubt session.
okay. No, means I'm not asking the answer. Just I cannot interpret with a set of questions. If only one question I can interpret that you
Yeah,
tell, the
so
other will be done.
yeah, that is okay. You just take this lecture. Maybe after this lecture, your doubt is clear automatically. Otherwise, we can solve that question. Okay. You have some doubt in the question, you're not able to understand it. So just go through this lecture. Okay, we are discussing the topic only.
Okay.
Okay, is this question clear to everyone?
Yes, ma'am.
Yes, ma'am.
This multiplication principle that we are doing, that is basically giving the number of permutations.
Yeah, you can see that if you it is permutation, okay, but in permutation also you have two things, whether the objects are distinct or not.
Okay.
Okay, so in the first one, the repetition is allowed, but in the second case, repetition is not allowed. So you can see that in the next one, in this one, yeah, we are taking distinct objects because the repetition is not allowed. Okay, and here you can repeat the objects. Maybe at these two places, we can have same letter as well. Okay. Okay, so the next example is, so there are 8 athletes who are taking a part in a race. So there are 8 athletes. So they are who take part in a race. Okay. So what are the possible ways the athletes can finish the
Factorial. 8 into 7 into 6 into 5 into 5.
Okay, so what are the possible ways that athlete can finish the race? Okay, and we are assuming that there will be no ties. Okay. So which means at one position, there will be only one person in.
Yes,
Not
8 factorial.
Yes, 8 factorial. So how are we doing it? So we have 8 different athletes. So 8 different positions will be there. Okay. So at first, suppose we have 8 different options,
7.
right?
Yes,
Then we
ma'am.
have then for the next we will have 7 options. Then we
Then
will
6.
have 6, then 5, 4, 3, 2, and 1.
1.
Okay.
5040. Ma'am, answer.
So you can multiply and you can get the answer. Okay. Okay. So now ultimately what we are doing,
Excuse
we are
me.
taking the factorial of it. So now we will see the factorial. What is the factorial of a number?
Excuse me, ma'am.
Hmm.
Can you explain when to use addition rule and multiplication rule? I'm getting a little confused.
Okay. So the thing is, addition rule we use when you have to select when only one out of the all the action is occurring. You have
Okay.
two actions A and B. Okay. A comma B. If there is A or B, and there
Okay.
can be A and B. So if they both are occurring simultaneously, if there is an AND condition, you will use the multiplication rule, okay? But if there is a OR condition,
Okay, ma'am.
okay, one is occurring at a time, not both together, then you will use the addition rule. Okay?
So in the case of the second exam, we have A and B. That is, we have to choose both, right? Not or. That's why we are multiplying.
Sorry, your voice was cracking.
Second exam. No, ma'am.
So your voice is
In the
not very clear
second
to me.
example, we have. It's okay, ma'am. I got it. Can you hear me now, ma'am?
Yes.
So in the second condition, we have to choose the AND condition, right? That is the multiplication. So that's why we are multiplying as 8 into 7 into 6 and so on.
Yes. So this is the like you want all the 8 places to be filled.
Okay.
So for the first, you are having 8 options, and then for next you have 7 options, and then for the next you have 6, and so on, like this.
Okay. Okay. Got it. Thank you.
So next we have a concept of factorial. So what is the factorial? Anyone?
It's the product of repeating the numbers of it is used for natural numbers till it goes to 2 or 1.
Yeah, so it is the product of first n positive numbers or counting numbers, right? So the product of first n positive integers okay, or you can say counting numbers also. Okay, so this is called n factorial, and it is denoted as this and this sign. Okay, and what is the formula? So if you are finding the value of n factorial, so this is n, then multiplied by n minus 1 into, so up to 1 you have to go, right?
Please scroll up a little. Just one.
So the value of 0 factorial is 1 by convention. So the value of 0 factorial, so this is 1 always. Now if you have n factorial, I can write it like this, n into n minus 1 factorial, right? So for
Yes, ma'am.
example, if I say, if you have 5 factorial, okay, so 5 factorial is what? 5
5
into
into
4
4
into
into 3
3
into
into 2 into 1.
Okay, so now if you look at this part carefully, this is nothing but 5 into 4 factorial,
4
right?
factorial.
So now you can relate this second point, that n factorial, we can write it as n into n minus 1 factorial. Okay, also
Yes,
we
ma'am.
can write it like this, 5 into 4
4 into 3 factorial.
Right? In that case, it is
Yes,
n factorial is equal to n into n
n
minus 1.
minus 1 into n minus 2 factorial.
Yes, okay. And now if I generalize this formula, so when I is less than or equal to n factorial, you can write n multiplied by n minus 1 into so n minus I plus 1 factorial, right? And this I should be less than or equal to n. Okay. So now if you want to express, okay, so you have to express 25 into 24 into 23. Okay, in terms of factorial. So how can we write it? So simply we can write first that it is 25 into 24 into 23. Now if I multiply and divide 22 into 21 up to 1 and divide with the same thing.
Yes, ma'am.
Okay, this is something we have multiplied. So we have to divide it also for keeping it the same. Now what can I write the numerator part?
25 factorial
So this has become 25 factorial
upon
and the
22
denominator is
22 factorial.
factorial, right? So this
Yes,
is how
ma'am.
you can use the factorial notation.
Ma'am, explain it again.
Okay.
Ma'am, can you please show the third remark? Okay, ma'am.
Ma'am, can you explain this once more, ma'am? This example.
Yes, ma'am. Why you?
So the question is that you have to express 25 into 24 into 23 in terms of factorial. Okay. So what we have done, we have just multiplied and divided by the same quantity. So we have 25 into 24 into 23. And we know that factorial goes up to 1. So if I multiply with the remaining numbers, 21, 22, 20, 19, up to 1, then in the numerator, it will become 25 factorial. And since we have multiplied this, we have to divide it also.
Ma'am, why you have divided 25 factorial by 22 factorial?
See, that's what I'm explaining to you. We have this part, 25 into 24 into 23. Okay, I have written this part here.
Yes, ma'am.
Then I have multiplied with this 22 into 21 into up to 1.
1.
Why? Because
Yes,
we
ma'am.
know n factorial, if you open n factorial, it goes n into
N
n
into
minus
n minus 1.
n minus 2
And
up
so on
to
to
1. Okay.
1.
So we already have 25, 24, 23. We have to multiply with the remaining values, right? And
Yes,
since you
ma'am.
have multiplied, you will have to divide also to balance the equation. Okay, we cannot change the quantity, right? So we have to divide also with the same. And now in the numerator, you can see it has become 25 factorial. And in the denominator, it became 22 factorial. So now you have expressed 25 into 24 into 23 in terms of factorial. Right? Is it clear?
Yes, yes, ma'am.
Okay, 1 minute. Okay, so is this question clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay, next we will study the permutation. So what is permutation? Why we use it?
Counting with order are known as permutation.
Arrangements.
Yeah, so in permutation, what we do, we have some number of objects, suppose n. You have n number of objects. You want to select some or maybe all. Maybe you are selecting r number of objects out of n, or maybe you are selecting all the n objects. So you are doing the selection of the objects first, and then you want to arrange them also. Okay. So arrangement is something which matters in case of permutation. So if you are interested in the arrangement of the objects after the selection of it, then you will use permutation. Okay. So we can write that permutation is an ordered arrangement of all or some of n objects. Okay. So suppose, and what is the formula of permutation?
N factorial upon n minus r factorial.
Yeah. So the number of possible, the number of possible permutations of R objects from a collection of n distinct objects okay. So this is given by the formula. So this is n factorial. Sorry, this is npr. Okay. So out of the n objects, you are selecting r and you are arranging them. So the formula is n factorial divided by n minus r factorial. Okay. And now keep one thing in mind, that here the objects are distinct. So this formula we use when we have distinct objects. We will see next, if the objects are not distinct, then how we do it. In the next part, we will see it.
N to the power r.
Yes. So, but you have n distinct objects and you are selecting r objects out of it. So we will use this formula.
Excuse me, ma'am. What at the beginning I was trying to ask is that that the multiplication rule we are using, that is basically npn, means how to permute n objects out of n objects. Is that like that?
Yes, yes.
Because
You can
actually there
directly
the
use
order
the,
was varying because when we are multiplying, the order is coming in that.
okay, see, not all the time you have to use the permutation or combination formula. So it might be different. Some according to the situation, you have to decide whether you have to use permutation or combination, or you have to use the multiplication rule or addition rule, or you have to use just some common sense and you have to do some multiplication and you have to find the answer. So according to the situation, you have to decide it.
Could you please scroll a little up for 5 minutes? Actually, I was disconnected. Before the definition of permutation, what you have written? Okay, just.
By the way, this PDF will be uploaded, so you can take the notes from there, okay? So now you can see, suppose if you have 3 A, B, C, 3 objects A, B, C, okay? And you have to take all the 3 objects, all the A, B, C, 3. So that take all at a time. So you have 3 objects. In how many ways you can select and arrange it? So we can directly use some formula, but you can use you can see how the formula is being made. So we have 3 ABC. So we can see that we can arrange ABC like this: ABC or ACB. Then it can be B AC or BCA. Okay, then CAB or CBA, right? So you can see that these many arrangements are possible. Is there any other possibility?
No, ma'am.
Right? These things we can use.
Yes.
So now you can see the formula also, that out of the 3, you are selecting all the 3 and you are arranging them, right?
Yes, ma'am.
So we can use the formula 3P3, right? So N
My
is also 3 and R
ma'am,
is
why
also
you have written 3P3? 3P3 matlab 3P2 na?
we have taken all the 3, not 2.
Will be 3P3, not 3P2, because we are not arranging 2, we are arranging 3, right?
We are taking all. That's what I have written in the first part. Take all at a time.
Excuse me.
3 letters, and in one arrangement there are 3 A, B, C.
So we have 3 objects, N is equals to 3 here. And we are selecting all the 3. In permutation, you can select all the objects also. It's not like you should select less number of objects out of the total. Okay, you can select all or some. In the definition also, you can see that a permutation is an ordered arrangement of all or sum of n objects. Okay, so in the first case, I am taking all the 3. So which means out of all the 3 objects, we are selecting the 3 objects first and then we have to arrange it. So it will be 3P3. So the formula is 3 factorial divided by 3 minus 3 factorial. So it will be 3 factorial divided by 0 factorial, which is 3 factorial ultimately. 0 factorial is 1. So it will be 3 into 2, which is 6. So now you can verify
Excuse
this
me.
thing.
Hello?
Yes.
Am I audible right now?
Yes.
Can we ask the doubts regarding, like, if I am having some sort of doubt in the lecture of the week 5, can I ask that?
Yes, you can ask.
Okay, so I have a little doubt. I already posted in the chat. There was an example in the week 5, the very last video in which we are taught about the permutation and all. There was a question in the example where we have given the ratio of 2 permutations and we have to find the value of R, and the ratio is already given. I don't remember the question
Okay, we
correctly,
will
but
solve the
yeah.
question. It will come after some time. We will solve it then.
Okay, thank you, ma'am.
So now you can verify with the formula also. It is coming out to be 6. And when we are normally making the arrangements of 3, and then also it was 6. Right? So the formula is verified. You can see here. Now we can take the 2 objects out of the 3. Okay, now take 2 at a time. Okay, so out of the 3 A, B, C, these 3 objects we have to select any 2 and we have to arrange it also. So the possibilities will be AB, BA, right? Then AC, CA, then BC and CB. These will be the possibilities, right? If we are
Yes,
taking
ma'am.
two objects out of the three. Now, N is 3 and the value of R is 2, right? Again, we can use the formula. So it will be 3P2 now. So this is 3 factorial and 3 minus 2 factorial. So 3 factorial divided by 1
6.
factorial. Again 3 factorial, which is 6. Okay, again you can see the formula is verified. Okay, is this clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so just remember one thing
Excuse me,
that
ma'am.
whenever you are using this formula 3P2, then the objects do not repeat itself. Okay, so repetition is not allowed in this formula.
Excuse me, ma'am.
Hmm.
Ma'am,
Yes,
the following question is about arranging in a pair, arranging all the three in the pair, right? All the possibilities.
you have to select two items out of all the three and then you have to arrange.
So we have to find all the possibilities to arrange these three items in the pair of two. That is the question, right?
Yes, yes.
Okay, so a little question. What is can you explain this question again? I joined a bit late. Just overview and some.
So you have three objects, okay? You have to select two items and you have to arrange it. So these will be the possibilities. First, I'm selecting A and B. Okay, then we can arrange A and B in these two ways. Then if I select A and C, right? Then in this two way we can arrange it. Then if I select B and C, then in these two ways we can arrange it. So
Wait a
total we
second.
can see that it is 6.
Wait a second.
Right?
No, not this part. The formula part. The 3 to the power of permutation by 2. The permutation part, right? No, that one. I
No,
mean,
this is the
explain the
formula that
permutation.
Hello.
This is permutation.
Hello. Am I audible right now?
Yes.
Excuse
I
me,
think
am I
this is
audible right now?
permutation only.
I'm just asking to explain the permutation of how you use the permutation formula for solving the said question.
That's what I'm explaining. But you are interrupting again and again. You want me to explain how I'm using this formula, permutation formula in this particular example, right? Yes, no.
Yes, okay.
Okay, that's what I'm explaining. You don't need to ask the same question and again, okay? So this is how we have done in normal way, right? Now, if you want to use the formula, what we have to do? You have three objects. You have to select two and you have to arrange. So definitely we will use the permutation formula, right? The formula is n factorial divided by n minus r factorial. The value of n is 3 and the value of r is 2. We will just put the values here and we will get the answer as 6. Now is it clear? How are we using the formula?
Yes, ma'am.
Yes, ma'am.
Wait a second. Just wait a second. Just 1 minute. So we have to reduce the n from r while doing the formula in the denominator, right?
Yes, it is n minus r factorial.
Okay, just okay. Okay, thank you to explain that. Can I ask the question now? Another question
No,
regarding
because
this formula.
what question?
So the example which was given in the last lecture of the week 5, there was
I
this one
already
example.
told you that we are coming to that point.
Okay.
Let me first explain the topics which are before that, okay?
Sorry,
And then
sorry,
we will solve
wait,
the question.
sorry for that.
So you are asking the question from the last lecture, right?
No, this one later question. The zero permutation will be 1, right?
Yeah, 0 factorial is 1.
0 factorial.
Yes,
The
the
one
value of 0
this.
factorial is 1.
Okay. Thank you, ma'am.
Okay. So now we have some special cases of permutation. if you have NP0, the value of NP0 according to the formula, it is n factorial divided by n minus 0 factorial simply. So this is n factorial divided by n factorial. Second, we have that NP1. So what we are doing? We are selecting one object out of n objects. So n factorial divided by n minus 1 factorial. Right? So n factorial, I can write n into n minus 1 factorial. Also, right? Which will be equal to n. Am I audible to everyone?
Yes,
Yes, ma'am.
Yes, ma'am.
Okay. So according to this formula, what it is saying that you are selecting one object out of all the n objects. So definitely if you use your common sense, definitely it should be n only, right? You have
Yes,
7
ma'am.
objects, you have to select one object. So you have
7
7
options.
options ultimately, right?
Yes,
So
ma'am.
out of n, if you have to select, you will have n options. That is a very clear thing. So we can write that there are n ways of choosing.
1 out of n objects.
Yes, one object out of
Excuse
n.
me. Am I audible right now?
Yes.
Hello?
Yes, yes, you are audible.
Can you explain the second one once again? The N, P, and the lower side, lowercase one. The second one.
So this is NP1. Okay. So out of all the n objects, you have to select one. So how many choices will you have? If you don't use any formula, suppose you have n t-shirts. Okay. You have to select n. You have to select 7. So how many choices you have? Tell me.
Wait a second, I'm a bit confused. Are there 7 t-shirt and I have to choose one? Or there are n t-shirt and I have to choose 7?
Value of n is equal to 7.
And I have to choose one t-shirt.
Yes. So how many
So 1 out
options
of
you
7.
have? 1 out of 7. So how many choices you have for it? Just a general question.
I will only have just one choice out of the 7, right? I can मैं बस एक ही ले सकता हूँ. साथ में से एक ही तो choice है.
But you have 7 choices. We are talking about the choices.
Number of ways, brother.
इसको ज़्यादा ही डिस्टर्ब कर रहे हैं.
So we have actually
next
7
we have-
choices, na, right?
Yes, we ultimately have 7 choices. There should be no confusion in this question.
Yeah, absolutely.
Yes. Okay, you have n objects, you have to select one. Ultimately, you have n objects, n choices, right? We are just verifying this thing with the formula. If you're not using any formula, then also you can answer this question. But we are studying this formula, so we have to verify it, whether these formulas are correct or not. Now you have n objects. 1 minute. You have n objects and you have to select n, which means you have to select all the
n factorial.
All the n objects that you have. So in how many ways you can do it?
1 way.
N factorial.
Okay, one thing. This is permutation actually. So you have to select all the n objects and you have to arrange it also. Not only the selection, we are arranging it also. Okay.
Then we have n factorial options.
Yes, so we have n factorial. Okay, so earlier also we were selecting one object, and if you are taking one object, then arrangement does not have any meaning, right? So the answer was n. Now you have n objects, you are selecting n, and then you are arranging it. So for arrangement, you will have to do, so it will be n factorial. So now we can say, so this is a general formula. So we can arrange n objects so which are all distinct. This we should consider. Okay, so we can arrange n distinct objects in n factorial ways. Okay, so whenever you are asked any question that you have 10 number of things or n number of things and you have to arrange it, you have to arrange all the objects that you are given, then it will be n factorial. Okay, now we can see a few examples. So from a committee of 8%, okay, so from a committee of 8%, in how many ways can we choose a chairman?
8 ways.
Let me complete the question first and then you should answer.
What is the number you have written? 8%.
Yes. Okay, so you have to select in how many ways can we choose a chairman and a vice chairman? Okay, and we are assuming that one person cannot hold more than one position. Okay. Now you should tell me the answer.
56.
Yes, ma'am. 8 into 7.
8 into 7.
Yes. So now you can think about this question in two ways. You can use the formula or you can just use some common sense and solve it. So we have to take we have to select the person for two different positions, right? Chairman and vice chairman.
Yes, ma'am. Yes, ma'am.
And the condition is that one person cannot take more than
Hold.
one position. So basically the repetition is not allowed.
Yes, ma'am.
So we have, for the first position, you have 8 options, and then for the next, you have 7 options.
7 options.
And this you can write like 7 into 8 also. Okay. So this is like for one position, you have 8 options, and for another position, you have 7 options. Okay. So this will be 56. Or you can think about it like this, that you have 8 options and you have to select 2. You have to arrange them also, right? Because
Yes, ma'am.
okay, why we are using permutation here? Because we have two different positions. Okay, so suppose you have two person A and B. So maybe you are selecting A as a chairman.
And B as a vice chairman.
Yeah, and B as a vice chairman. And maybe you are selecting, you have selected 2 person, again the same 2 person, A and B only out of the 8 person. But this time A is being the vice chairman
Vice
and
chairman.
B is being the chairman. So these
Chairman.
two cases are different, okay? So that's why we have to use permutation here. If we
Yes,
just
ma'am.
have to select 2 person, then we can use combination. But here the arrangement matters. Okay, so you should know when arrangement matters or not. So by reading the question, you have to understand this thing. When we have to use permutation, when we have to use combination. Yes.
Ma'am, here some position was mentioned like designation chairman, vice chairman. So we know that 2 persons can become 2 different things. So here position matter, but and also order matters. But in a previous example, you are showing with alphabet. Means suppose the question is like this. Means I faced this in the assignment. Like I have 4 alphabets A, B, C, D, and it is only written that how many ways can I select 2 alphabets. Nothing else is mentioned. So in that.
Yeah, so in that case, you have to use combination. If you just have to select and not arrange.
Means if only the word select is mentioned, then we have to use combination.
it's not like it will be mentioned arrangement or not. You have to understand the question. Here also it is not mentioned that you have to arrange or you don't have to arrange.
No, here
But
we
it
can
is,
understand that there are the two
yeah, so
different
it
roles
will be
and one.
understood from the question. Okay, if you just have to select, you will use combination simply.
I mean, that is what I'm asking. That in the question, if it is asked, the word select is mentioned, select. So then we have
Yeah.
to use combination.
Yes.
Okay.
If you just have to select, you use combination.
And if it is something asked like this, what are all the possible ways to do it? Means suppose it is asked like that, A, B, C, D, 4 alphabets there. What are all the possible ways to choose 2 out of 4? So then we have to use permutation.
Combination tells you all the possible combinations only for selecting.
Okay.
Okay, so now according to the formula, it will be 8 factorial upon 8 minus 2 factorial. So again, 8 factorial divided by 6 factorial.
6 factorial.
8
so
into
it will
7
be-
is equal to 56.
Okay, so again it is 56. So now you can see that by both the methods, you're getting the same answer. Okay. So now are you able to understand how this permutation formula is working like this?
Yes, ma'am.
Okay, so ultimately we are doing the permutation, but we are just writing 8 into 7. So it's like the form of permutation formula only. Okay. Okay, the next is next example is that you have to create a 4-digit number using the digits 1, 2, 3, 4, and 5.
5 factorial.
Why 5 factorial? You have to make a 4-digit number, okay? And not 5. Okay, so we have 5 different options. And you have to
120, ma'am.
select 1 minute. So we have 5 different options, okay? And we have to make 4-digit numbers. So we have to select 4 objects out of these 5, and then we have to arrange. Okay, because we are making a number. So arrangement will matter here. Order matters here. So we have to use permutation, it is clear. Right? Out of 5, we have to select 4. Okay. So this is 5 factorial divided by 5 minus 1 factorial.
120,
5
ma'am.
minus 4 factorial. 5 minus 4 factorial. So this will be 5 factorial. 5 factorial is correct. So this is 120. Right? Is this clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes, ma'am.
Okay, or you can solve this question like this, that you have 4 places to fill. Okay, so for first place, how many options do you have?
5.
5, right? Then for the next, you will have
4.
4 options because repetition is not allowed.
Yes,
Then you will
ma'am.
have 3 options.
3, then
Then
2.
you have 2 options, right? So again, it is 5 factorial only. Okay, so you can use either of the method. Okay, both will give you the same answer. Okay, now in the same question, if I ask that how many of these will be even numbers, if you have to make even numbers only,
What were the digits?
1, 2, 3, 4, 5. Okay, so these 120 contains all type of numbers, but you have to select, you
Even
have to see
numbers.
how many numbers are there which are even.
Yes, ma'am.
Okay, so now you have to select the numbers accordingly. Okay, So how will we proceed this question?
Ma'am, in one's place we have only two options, either 4 or 2. Then we
Yes.
create even number.
Yes, correct. So we have 4 places, right? We have to make 4-digit number. And out of the given digits, 1, 2, 3, 4, and 5. So if the number ends with 2 or 4, then
Then we
only it
can
can be
create
a, yeah, then
even
it
number.
can be a, yeah, then it will be a even number. Okay, so if the number ends with 2 or if ends with 4, right? So at the last place, we have only one option, right? We can already fill it.
Yes, ma'am.
Now we have to see how many numbers, choices we have for the remaining 3 places. So 2 we have already filled and repetition is not allowed. So out of, for these 3 places, we have 1, 3, 4, and 5, right? These choices we have. And here we have filled 4 at the last place. Okay, this is not 1 by 2 and 1 by 4. Don't get confused, okay?
I mean, the first place can contain 2 also, because even number has to end with 2, but can start with anything.
But repetition is not allowed.
Okay.
Okay, it is the part of the same question, okay? It's not a different separate question. So you can see that repetition is not allowed. So now we are left with these choices 1, 2, 3, and 5. So these 4 numbers. So we have 4 options, then 3 options, and then 2 options,
Then
right?
2 options.
And here also 4,
Yeah.
3, and
As
2. Okay. So these
Ma'am,
contain
can you please
4.
repeat this once? This
Yes, I will.
example.
Yes, 1 minute. So this one contains 24 and this contains 24. So total will be
48.
48. Okay. So 24 plus 24, the answer will be 48. Okay, so I am repeating this question again, the entire question. You have these four digits, 1, 2, 3, 4, and 5. Okay. You
Ma'am,
have to
this
make a,
example I got it. Next
okay,
example, even
okay,
how many? Yes, ma'am.
okay. So you have to make a even number. So for even number, the number should end with a multiple of 2, right? So in this question, we are given 1, 2, 3, 4, and 5. So we have 2 or 4. If the number ends with 2 or it ends with 4, then only it will be an even number, right?
Yes, ma'am.
So there might be numbers which are ending with 2. So we have already filled like 2 at this place. So we have only one option for the last place, right? And if you are
Yes, ma'am.
filling 4, then also you have only one option. Okay. Now we have to fill the other places. And in the question, it is given that repetition is not allowed. So for the other 3 places, we have these options 1, 3, 4, and 5. For the number which is ending with 2. Okay, and for the number which is ending with 4, we have these options 1, 2, 3, and 5. Now out
Okay,
of
ma'am.
these 4, okay, or you can write it like this also, that it is 4. Out of these 4, you have to select 3 and you have to arrange it. Okay, so this is nothing but 4p3 only.
Okay, ma'am.
Calculate the value of 4p3. Okay, it will be 4 factorial and 4 factorial will be 24 only. Okay. Now you can see that how permutation is working here, this formula. Or if you use just some common sense and solve this formula.
Excuse me, ma'am.
Yes.
Ma'am, I want to ask a question. Means the language, particular language is bothering me a lot. Means suppose I am asking the question, you consider it as a normal question only. Means not here. Means suppose directly I'm asking that there are just the how to interpret. Means there are 36 students and if 3 students complete a task, top 3 students complete a task, then they will be awarded. So how many total ways they can be awarded? This is what is the question. Nothing else is mentioned. So if we go just by the multiplication principle, then we have to do accordingly. First 36 possible ways, then 35, 34, then multiply. But then the question comes that is it permutation or combination? Means here the order should not matter. Means they have not mentioned first, second, or third position. They have just mentioned that they will award any 3 students who complete the task. So their
We are
combination
just taking the top 3.
they are taking 3 students who complete a task within say 1 day. So any 3 students who do that, they will be awarded out of 36, or say anything. So how many ways the award can be given? So so if we just go by the multiplication principle, then it is coming under a permutation, means 36, 35, 34, like that. But then the question is coming that here the order matters or not. Means in this type of problem,
It
I'm not able
depends
to,
on one position, there is only one person allowed or not.
means it is just mentioned out of 36 students, 3 students are to be awarded who complete a task within 1 day. So how many ways they can be awarded? That just this is mentioned. So in this type, when only this is mentioned and nothing else, then how to
Yeah, so
think?
in that case, arrangement does not matter. So you will just select the 3 students.
The multiplication principle that we have done in the beginning, it is the applicable to all. This is where it's becoming contradictory. Means multiplication principle does not bother whether it is selection or not. But I mean, in that way, I'm getting confused actually.
Okay, we'll see your question in the doubt session. Okay.
Now, after the class, can I show just one question? This will clear many other questions also.
Okay, fine.
Okay, ma'am, thank you.
Okay, is this particular question clear to everyone? Any doubt in this part?
No, ma'am.
No, ma'am.
I mean, this particular question, we basically applied the multiplication and addition rule together. We consider 2 cases where at the one we are fixing 2 at last, and in the second one we are fixing 4 at last. Since they're 2 separate events, we are adding, but in each event they're happening simultaneously, so we are multiplying. Is it like that?
We have to fill all the 3 places at the same time, so that's why we are multiplying it.
Okay.
You have to
Okay,
select
understood.
4 numbers all together, then only a 4-digit number will be formed.
Okay, ma'am.
Okay, so selection
Ma'am, could
is
you please
all
repeat?
together.
Ma'am, could you please repeat the examples, please? Didn't understand.
I have already explained this question 2 times. Okay, this is the last time I'm explaining the same question.
Okay, ma'am. Okay. Thank you.
You have 5 digits. Okay, 1, 2, 3, 4, and 5. You have to select 4-digit number. You have to select 4-digit first. And since you are making a number, so the order will matter in this question, right? So we will use the permutation formula. So out of 5, we have to select 4 and then arrange. So 5p4, by the formula, you will get the answer 120. Okay. Or you just use this way. You have 4 places to be filled. For the first place, you have 5 options. And since repetition is not allowed, so for the next place, you will have 4 options. Then you have 3 options, and then you have 2 options. So in this way, it will be 5 factorial. Is it clear now?
Yes, ma'am.
Similarly, here
Okay,
the
ma'am.
number ends with
Yeah,
2 and
clear,
4, then
clear, clear.
only it will be a even number. Okay. So you have to fill all the other places from these choices. And the repetition is not allowed. So it will be 4 into 3 into 2. Okay. So it will be 24 and 24. So this is this 24 is for the numbers ending with 2, and this is for numbers ending with 4. So total will be 48. Okay.
Okay, ma'am.
Excuse me, ma'am.
Yes.
Is there any specific formula if repetition was allowed in permutation?
Yes. Yes, we are discussing that formula now. So we have some other kind of permutation formulas as well. So the next is, if the number of possible permutation of R objects, the number of possible permutation of R objects from a collection of n distinct objects. Okay, when the repetition is allowed. This is the formula for it, for this condition. the number of possible permutations of R objects from a collection of n distinct objects okay when repetition is allowed. Okay, so this is given by the formula. So this is like you have, so it will be n into n into n up to r time, right? This will be r times.
Power R.
So this will be n to the power r. Okay. So earlier we were using it. So in this question, you can see that we were doing like 5 into 4 into 3 because the repetition was not allowed. But now if the repetition is allowed, then for all the places you will have 5 options, right? So it will be 5 to the power 4 here. Okay, so that's why. So the number of possible permutations of r distinct objects. So out of the n, you are taking r, and repetition is also allowed. So it will be n to the power r. Okay. And one more formula is there if the objects are not distinct, if the objects are repeating itself. So objects are not
Excuse me, ma'am.
distinct. Yes.
Hello.
Yes.
Ma'am, one query means here what you have said, here it is mentioned that repetition is allowed, and it is also mentioned that it will be permutation, means order is mattering. So that it is giving to rise n to the power r by the multiplication rule only. But means suppose what you have earlier told that in the question if it is mentioned only selection, then we'll use combination. But means I face this, so I'm telling means suppose
See,
it is told
it's not
that
about one thing. You have to take all the conditions. You should be careful about everything. And then you have to decide, you have to use permutation or combination or this formula or another formula.
no means suppose
In
we
one
have to
question, you
consider
might,
only combinations, and in spite of doing combination, repetition is allowed. Then what is the formula?
sorry, what?
I mean, suppose this is permutation and repetition is allowed, but suppose you have to only select and the repetition is allowed. Means the combination and repetition. So in that case, what will be the formula?
You give me an example, then I can explain. We will
Means
see
this is
this type of
basically
question. Okay, we will discuss this type of question in the doubt session. Okay, I will take this type of question and then we will discuss it where this condition comes. Okay, so if objects are not distinct, the number of permutation of n objects when p of them are of one kind and the rest distinct, so this is equal to, so this is n factorial divided by p factorial. Okay, now we have more than one objects which are repeating itself. So in that case, the number of permutation of n objects okay, so if p1 is of one kind. Okay, and P2 is of another kind, is of second kind, we can say. And so on. Pk is of kth kind. Okay, so this is given by, so this will be total n factorial, and then we have to divide by the number of objects which are repeating itself. So this will be P1 factorial. P1 is of one kind, then P2 number of objects are of one kind, and then similarly Pk factorial. Okay, so suppose you have a
Could you please
word
explain
data.
this one again? The formula I have seen, but the concept, could you guys explain once again?
Yes, ma'am.
Suppose you have a letter, you have this word data, okay? You have to arrange the letter of these words. So in this question, you will apply it, okay? So this is the word given to you. You have to
24
use
ways.
the. Don't tell me the answer. Tell me how did you solve it.
It is a four-letter word, so numerator will be 4 factorial, and there are two
4 permutation
denominator is
upon
2 factorial.
2 permutation and
Yeah. So we have in total we have four objects, okay? But all the four are not distinct. You can see that this A and this A are same. So if you have objects which are not distinct, what you have to do? The formula is n factorial divided by 2
Yes, sir.
factorial or this. So it depends, like if you have one object
ma'am
which is
4
repeating, or you
factorial
have.
upon 2 factorial.
Yes, okay, let me explain it. So you
Yes,
have
ma'am.
to use these two formulas, okay? So you have to decide, like if more than one object is repeating, you have to use this one or this one. These two are actually same. So here you can see that only A is repeating and it is coming 2 times. So the answer will be 4 factorial divided by 2 factorial. Okay. Now if you have a different word, statistics. Now here you can see that more than one objects are repeating itself. So total we have 10 objects, right? Total we have 10. But
10
some of them.
factorial upon 3 factorial into 3 factorial into 2 factorial.
Okay. So total we have 10 objects. Okay. Now S is object which is repeating 1,
3
2, and
times.
3 number of times.
3 factorial.
Then we have T. T is also repeating 3 times. Okay. Then we have A is coming 1 time only. It is not repeating itself. Then we have I.
2
I is
times.
coming 2 times. Right. So we can see that these 3 objects are repeating itself these number of times. Okay. So the answer will be total number of objects factorial 10 factorial, then divided by 3 factorial, 3 factorial, and 2 factorial. Is this clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes.
Here in the total number of ways, we are basically permuting 10 out of 10. But here the repetitions are there. But if it is just that in number of ways in which we have to select 2 out of 10 with the repetitions, then we have to do 10p2, then by 3 factorial, 3 factorial, 2 factorial, like that.
Sorry, what? I don't understand.
I means here we are basically in the total number of ways we are permuting 10 out of 10. Means out of the 10 given, we are selecting 10 and then permuting, and we are
Yes.
considering the repetitions. But if it was given that given these repetitions, how if we are if we have to select 2 out of 10 and then permute, how many ways can we do that?
You
So
have
the
to
new
do it. How? Then it is a different kind of question. You have to see all the cases. You will select R objects out of that, and then you will apply this formula.
And so if you have to select R objects given the repetitions, so will just the numerator be 10 PR instead of 10 factorial, or some other case will be there?
So in that case, you will first select it 10 P2 or whatever it is. See, that is a mixed kind of question. You are selecting first. So for selection, you can use combination formula. And then out of the selected ones, you have to arrange.
Okay.
And then according to the given condition, you will use the formula. Okay, so that's why I'm saying that it's not always one particular formula that you have to use. According to the question, you have to decide what formulas we have to use. It can be using so many different formulas in one question also. So that depends on the question. So you have to be careful about when you have to use combination, when you have to use permutation. It's not like you just remember these formulas and you will be able to solve. Yes.
Now I have a doubt in activity question.
Activity questions we will take in the next session, doubt session, okay? Because
Ma'am,
for
it's
this session,
related to what you're explaining right now. If you're asking.
yeah, still we can discuss in the doubt session because we have to take the summary in this session only. We have only half an hour left. Okay, for the questions we
Okay.
have doubt session, so we can discuss it there, okay?
Okay.
Hello.
Yes.
Yeah, ma'am. Can you help us, interpret a question, whether that question we have to interpret a permutation or a combination from the language of the question?
Okay. What is the question?
No, there is no particular question. I'm just asking how to interpret, like from the language of a question, that whether we have to use permutation or a combination.
See, the only thing I can say is that if you're doing the selection only, you're just selecting R number of objects out of some objects. So selection means you can use combination. And you can see in the next week, you will see that there is a relation between combination and permutation. So the thing is, in the permutation formula, we do the selection. We are actually using the combination formula, and then we are just multiplying a few something like R or R factorial something, and you will get the permutation formula. So in the combination formula only, you are adding a term for the arrangement, R factorial, and you get the permutation formula. Okay, so these two things are related to each other. So if arrangement matters, you have to use the permutation. If the arrangement does not matter, you have to use combination. Now, after the reading the question, you can decide. There is no general thing. This is the only concept I can say.
Okay.
Okay, so don't worry. We
Yeah,
will
ma'am.
take the questions in
Can
the
you
next
help?
session, and we will see how this thing works.
Ma'am, this is a simple question. Like, in how many ways can a test paper of 6 questions be attempted? Each question being a true or false type. So here R will be equal to 3 or 2.
Sorry?
In the,
You have question paper?
yeah, I sent it in the chat. No.
Okay, I already told that we will take the activity questions in the next session. So
Ma'am,
please
I'm
don't
unable
interrupt the
to
class
understand
again and
it.
again. We just have half an hour left, so we have to complete the other topics as well, okay?
Ma'am, just a sec. Could you please scroll a little bit up? Just a second.
If I
One
have
more
already
scroll.
told one thing, then you should be careful about this thing. It will only disturb other students. So for these
Ma'am,
topics,
will
you
you
have
please
to be
mute
a little
everyone because
patient.
this causes problem in class.
Sorry, what?
Ma'am, please mute everyone. They are interrupting the class.
Okay, we have this topic left. So I'm saying that if you have any particular question, we will take it in the doubt session, okay? Okay, what do you understand by circular permutation?
It's related to seating arrangement.
So circular permutation is like you are arranging the items according to the circle
There is no
or a round
starting or
table.
ending.
Yes, so in the previous questions, we were doing a linear arrangements, okay? Like this A, B, C, and D. So this is a linear arrangement, but here you will arrange the things like this, okay? No starting and ending point, so it is a circular arrangement. Okay, and since we are arranging the things, so this is why it is permutation. So when you are taking the clockwise and anti-clockwise, clockwise are different. So first of all, suppose we have 4 letters A, B, C, and D, which we have to arrange
Your voice is coming
circular.
very low. Your writing, I can see, but what you are saying, I cannot understand.
Is it so for everyone?
No, it's okay, but
No, ma'am, it's okay.
now
Ma'am,
it's
now
okay.
now it's okay. Now it's okay.
Okay. So you are arranging the things according to a circle, okay? So which means you can do this thing like this, A, B,
Ma'am, can you
C,
please
and
repeat
D.
what you say about circular permutation?
Yes.
Ma'am, what you say about circular permutation?
Sorry, your
Beginning, I
voice
could not
is
hear.
not clear to me. Okay, we have to arrange these 4 according to a circle. In a circular manner, we have to arrange it. Okay. So this
Yes, ma'am.
is one way, okay? A, B, C, and D. So if you write the same thing like this, so A, B, C, and D, and then if you write A, B, C, and D, and you write A, B, C, and D. So in circular permutation, you can see that all these 4 are same actually,
Yes, ma'am.
right? Because you can see next to B, A and C are there.
Yeah.
Here also next to B, C and A are there. Here
Yeah.
also next to B, C and A, next to B,
They
C
are
and A.
there.
Okay, so that's how it is different from the linear arrangement.
Sorry, I'm how different from the arrangement?
Okay.
Could you please again say?
So these
Hello.
4 are same. Now we have to worry about the.
Hello.
Yes.
Could you please explain how they're different from linear? I could not hear.
Yes, ma'am. I didn't get it.
Okay, see this is, I can write A, B, C, D, suppose. This I can write D, A, B, C. This I can write C, D, A, B. This I can write B, C, D, A, suppose. Okay. So now in a linear arrangement, these 4 are different, right?
Yes, ma'am.
But here you can see that all these 4 are same. If you see the arrangement next to A, D and B are there. Here also next to A, you can see D and B are there, right? So these 4 are actually same. Now how we can arrange the 4 things according to a round table. So this line I will write later. So what we do in arranging the things in a circular manner, we just fix one position. So suppose I am fixing the A letter at this top position, okay? So I'm writing A at this position only. So how we do it? We fix one position and then we arrange the other objects among these positions. So we can write like this, that A, B, C and D, or we can write A, C, D and B, or we can write A, D, B and C. Now you can see that these are different arrangements of A, B, C and D according to a round table.
Yes, ma'am.
Okay, now you can see next to A, B and D are there. Here next to A, B and C. Here next to A and D are there.
P and
Now we can have this like it. So A, B here, D here and C here. Okay. And now here, so A and just I'm just flipping these positions. Okay. So this is like mirror image of each other. A, B, D.
Excuse me, ma'am.
So this will be A, D,
Excuse
C,
me, ma'am. Hello.
and B. Yes.
That means I'm not able to get
Excuse
the
me,
means.
ma'am.
So,
Can I ask a question regarding this one?
ma'am, I'm
The
not able
circular
to get
arrangement?
means when the arrangement will be same and when the arrangement will different. Means when we are arranging in some cases it is becoming same, some case it is becoming different. I'm not able to get when
Like,
we.
yeah, ma'am, the same question here. Just want to know how to identify when the question is asking that it will be a round table or not round table. Like how to identify the need.
That will be mentioned in the question. You have to arrange it in a circular manner or a round table. Round table is round. That is understood. If you
Okay,
have to
and
arrange
this,
in a circular manner, it will be mentioned. Otherwise, it will be a linear arrangement.
okay, can you give an example of such a question itself as well? Like solution of such
Yeah,
a
it will
question
be
in
like
which
that,
we have
that you
to
have
solve
to
regarding our
arrange. So it
later
will be
on.
something like you have seven people and you have to arrange them in a seven in around a round table, or you have a necklace, you have to arrange it. Something like that will be given.
Excuse me, ma'am. Here my question was yeah,
A,
given
B,
it is circular
C, D, you
permutation,
can
but
see.
how to identify which arrangements will be same, equivalent, or and which will be different? Means here initially you had shown some arrangements which were same exactly.
Okay, so yeah, see, the thing is, you are saying A, B, C, D. You are
No, we are
following
not
this manner:
audible.
A,
Could you please
B,
raise the?
C, and D. Yeah, that's what I'm explaining. Just be patient about these things, okay? Don't be in a hurry. You just see this example. I kept A here, then I am taking B, C, D, this arrangement only. Then B, then C and D. Then I put the A here. Again, same thing: B, C, D. Okay. Then I put the A here, B, C, D. Then I put the A here, then B, C, D. This is same. If you want to take a different kind of arrangement, then you can take like this. Then suppose if you are taking A, C, B, D. So this is A, C, B, and D. Now,
Excuse me, ma'am,
suppose
your
A.
voice is not audible.
No, it is audible. Very well audible.
A,
Audible,
C,
audible, audible, madam. Audible.
Yeah,
B,
No,
and
it
D.
is.
Okay, something like that. Then it is A. So what I'm doing, we have same thing. We are just rotating it, right? First A was here, then C, B, D like this. Then A is here, then again C, B, D like this. Then A is here, C, B, D. So these four will also be same. A, C, B, D. What we are doing, we are just rotating it. Okay, we are not changing their position. We are just rotating it, right?
So, ma'am, all
Yes,
these are
ma'am.
same.
So
All these
that's
are
how
same
these four are
circle.
same.
Means basically the sequence is
Okay,
same. Means
so these are same.
hello,
Hello.
ma'am. Basically means the sequence is same. Means whatever in the initial part.
Yes, yes, because it's a circular table. So you cannot say it's a starting point or ending point. So you can see A, after A, C is coming, and after C, B is coming, and after B, D is coming. And it is same for all these four, right? Here we have 4, so we can have 4 things, like 4 type of arrangements. Okay, here also you can see, so this is how these 4 are same. You can see, now is it clear in these figures?
Yes,
Now,
ma'am.
if you look at these figures, you can see A, then B, then C and D. But here it is A and then after A, C is coming. After C, D is coming. Then B is coming. Here you can see after a D and after a D, it is B. So these are the different kind of arrangements of these letters. Okay. So now how we derive the formula of it? So this is, we are fixing the position A. So you can fix any of the letter and still you will get the same. So suppose we are fixing B.
Ma'am, these all 6 are same arrangements.
These all 6 are different arrangements.
Okay, ma'am.
These are different, okay? These are not same, these are different. So how the formula is derived is, you are fixing one object. It could be any of the object. And then what we are doing? From the remaining objects, we are arranging it. Okay, so how we are arranging? B, C, and D we are arranging, okay? And the A is fixed. So first B was here, C is here, and D is here. Now in the next you can see B is here, C is here, and D is here. So the positions of B, C, and D are changing. So the formula is n minus 1 factorial.
Ma'am, your voice is very low.
Okay, now?
Yes, ma'am. Now it's correct.
Okay, so what we do in circular permutation, we just fix one position and we arrange the remaining objects. So the formula becomes n minus 1 factorial.
And why do we fix that one object? Means all the objects should be arranged.
So the thing is, you can fix any of the objects. If you fix B also, then also you will get the same kind of arrangements. So what we do, we just fix one position and we do the linear arrangements in it.
Okay.
So this is how the formula will be. The number of arrangements, the number of ways, and distinct objects can be arranged in a circle. Okay. When clockwise and anti-clockwise are different. So I will discuss this also. What is clockwise and anti-clockwise? So clockwise and anti-clockwise are different. Okay. So in that case, it is equal to n minus
minus
1
1 factorial.
factorial. Okay. So now if you look at these carefully, 1 minute, let me just clear it a bit. Now look at these figures again carefully. So the first two, these two, you can see the mirror image of each other. A here, C and C are same. We are just flipping these two, right? D is here. And in this, it came to the right side. So you can see that these two are the mirror image of each other.
Yes, ma'am.
So if this is clockwise, then here we are going anti-clockwise, right? Here we are going like this, clockwise, A, B, C, and D. Here we are going like this, A, B, C, and D, in this way. So these two are anti-clockwise. So if these two are anti-clockwise are different, if we are considering these two are different, then the number of ways will be n minus 1 factorial, right?
Yes, ma'am.
Okay. Now suppose if we are saying that these two are same. So when these two might be same, if you have some beads, if you are making a necklace, when you have some beads, which are similar. So if you flip this, or you take mirror image, if you flip this to the other side, this will look similar. Again, it will be same kind of thing, right? So in
Yes,
that case,
ma'am.
we say that the clockwise and anti-clockwise are same. But if suppose these A, B, C, D and are people, and if you are changing their position, the arrangement will be different, right? In that case,
Yes.
we say that these two figures are different. But if you have the same object, anti-clockwise and clockwise will be same. So then in that case, these two figures will be same. Okay, these two will be same and these two will also be same. If they are if anti-clockwise and clockwise does not matter. So actually these two you can see it carefully that these are the mirror image of each other. Okay, again
Excuse
A
me, ma'am.
here, D here.
Excuse me, ma'am.
Yes.
Ma'am, so if we are
Yes.
dealing with the beads question or garland question, maybe in the same scenario, so that
Yes.
means we have to do factorial n minus 1 factorial by 2.
Yes. Okay, so we have the formula when we have clockwise and anti-clockwise are same. Okay, next is that formula only. Is this thing clear to everyone?
Yes, ma'am.
So I'm writing the formula here that if clockwise and anti-clockwise are same, okay, then it will be n minus 1
Ma'am, again your voice is very
factorial
low.
divided by 2. Okay. Is it clear
Okay,
now?
ma'am. Yes,
Yes,
ma'am.
ma'am.
Okay, how the formula is working?
Yes, ma'am.
Okay, so the thing is, the number of arrangements will become half. Okay, because the one arrangement will have its mirror image.
Yes,
So the
ma'am.
number of arrangements will become half of it. So it will become n minus 1 factorial divided by 2. Okay, now you can understand this with figure. Is it clear or anyone has
And
any
how
doubt?
can clockwise and anti-clockwise be same? Means the second condition you mentioned.
That's what I gave the example. Suppose if you have a bracelet where all these beads are of same kind, same color, same size, everything is same. Then can you identify which is, if you flip it, rotate it, everything will be same, right?
Yes.
If you flip it, suppose, if you take mirror image or a flip it, then it will
Voice.
be same, right?
Ma'am, your voice is very low.
Okay, there might be some issue. Okay, so in that case of thing, clockwise and anti-clockwise will be same. Or otherwise, in some questions, it will be directly mentioned or you have to understand it.
That means if the elements are not distinct in circular manner, then there will be only one possible arrangement.
No, it's not like that.
That means the logic way
See, the
explained
thing
that we
is,
are fixing
mirror,
one element and then doing the others. So that is when the elements are distinct. But suppose we are fixing one element, then all the other elements are same. Then one possible arrangement is only happening.
no, so, no, I will not say the color of the beads are all same, but the thing is, color might be different. In that case, arrangements will be different. If everything is same, then the arrangement will not matter. But suppose the colors are different, okay, and if you flip it, this object will still be the same, right? You cannot flip this circular table and the people, but you can definitely flip this thing.
Yes.
And it will give you the same object.
Okay.
So here the mirror image will be same. So in that case, clockwise and anti-clockwise will be same. Okay, color are different. I will not say the color are same. Not everything will not be same, definitely. Now are you able to understand?
Yeah, ma'am was explaining the third one, CDBC.
Which one? These two? Which third one?
Yeah, ma'am. That's it. I understand.
Yeah, so you can see like this is A, this is A, this is B, and here also B. Now you can see at the left side it is C, and in this you have at right side. And here at right side you have D, and here you have it at left side. So these two are actually mirror image of each other. If you understand what is mirror image,
Okay, ma'am.
if I make this figure here, this is A, this is D, this is B, and this is C, right? Now can you
Voice
understand?
is low again.
Ma'am, your voice is low.
Now,
Yes, ma'am.
are you getting what is the meaning of a mirror image here?
Yes, ma'am.
Yes, ma'am.
Is it clear now? Okay.
But
Yes, ma'am.
mirror images are not the same. This mirror image, two images.
Yeah, here in the first case, the two mirror image are not same. These two are different arrangement. But if you are considering it as same, then the formula will be n minus 1 factorial divided by 2. Otherwise, these two arrangements are different.
Please give an example how the clockwise anti-clockwise could be same. Means the here whatever mirror image that is shown, those are different, and mirror images should be different. But
That's what I explained to you. This example. You solve the questions of activity, you will understand it. Most of the cases it is different, but some of the cases it might be same. You just take different kind of scenario and think about it when it can be same and when it can be different. If you're talking about the people, it will always be different. Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Ma'am, can you do any examples from?
Yeah, I could do actually, but the time is not, we don't have enough time today. So we will solve the questions in the next session because you have your maths one session also.
Okay, ma'am. Thank you.
Only 5 minutes is left. The quick summary of the
Again,
permutation
your
thing.
voice is very low.
Please adjust it for the 5 minutes. I cannot do anything actually. So you have permutation. Okay. In permutation, you have two things. When the objects are distinct, okay, and the other was when objects are not distinct. So right, these two conditions we have. So objects might be same or might be distinct. So when objects are distinct, in that also we had two conditions, right? When the repetition is allowed and when repetition is not allowed. So if the repetition is allowed, two things we have here. So repetition is allowed and the objects are distinct. What is the formula we studied? So you have an objects are distinct and repetition is allowed. What is the
N
formula?
power n power r.
Yeah, it is n to the power r. Okay. And when repetition is not allowed, then we have
N
this formula
factorial.
n pr.
Yeah.
Repetition is not allowed and the objects are also distinct. So we had the simple formula of NPR. So this will be simply n factorial divided by n minus r factorial, right? Now we studied this formula when objects are not distinct, okay? What we were doing, it was n factorial divided by p1 factorial, okay? P1 objects were of same kind, then p2 factorial, right? And then pk factorial, right? So these are the different kind of things we have studied. So objects are distinct or not, you have to decide, and repetition is allowed or not. And then we studied about the circular
Excuse me,
permutation.
ma'am.
Yes. Yes, yes.
Hello,
Yes.
ma'am. Am I audible?
Yes.
I mean, I have just sent one question in the chat. If you could explain, many other questions should be clear. Just one question after this. Means I am not asking for the exact procedure, but just a concept I cannot understand. Initially asked also, but since I did not give the question, it was not clear. Hello,
Yeah, 1 minute. Let me complete it first.
are you speaking?
Yeah, let me complete it first and then we will take that. Otherwise, I will take it in the next session because the time is over. So when in circular permutation, we had two things. The clockwise and anti-clockwise are different. And when clockwise and anti-clockwise are same. Okay. So when these two are different, the formula is n minus 1 factorial, right? And when these two are same, then the
minus 1 by 2.
formula is n minus 1 factorial divided by 2. So these things we have studied in today's session, right?
Yes, ma'am.
We have discussed these things. We could solve that question which someone was asking about the finding the value of R, but the time is not there, so we will discuss those questions in the next session.
Ma'am, I
Ma'am,
even not yet
combinations.
to solve, but just one concept I need to ask. Could you please? I have sent in the chat recently.
Ma'am, can you explain combinations?
Combination is in week 6, so we will take that in the week 5.
Ma'am, I have a general question. Hello, can I ask?
Yes. Yes, yes.
I have submitted the week 4 weeks assignment. And what if I choose the only 3 course in first term? Then I will have to start from 0 for one course, for one subject.
I know I'm not sure about these things, so you can ask to support team regarding these kind of queries.
Yes, whomever it is, it's the same, because if you are continuing the same semester, you can continue with the four from the for week 5. But if you are not continuing, to redo everything.
No. If I choose the only 3 subject in the first term, then
Okay.
will I have to start from 0 for one subject? Matlab, from first week.
Yes, that's what I'm saying. That's what I'm saying. Now that whatever you are continuing with all the week 4, that you can get the score, everything credited, or you can continue with the same grade if you continue in the same semester. If you take one out of the 4 subjects, if you drop one in the coming semester, you need to start from week 1.
Thank you.
Like for example, that you do all the till the full thing, but for example, if you are not cleared or something, you qualified for the quiz 1, you qualified for quiz 2 and all the thing, but in the end term you didn't clear, that you can in the following semester you have the option again. In the following semester you get only option that you don't have to do all this week thing exercise, you can directly go for the end term exam, provided you feel that your score is sufficient enough that you need to do only the end term.
Okay. Thank you.
Okay.
Excuse me, ma'am. Hello.
Thank you so much, ma'am. Thanks a lot.
Excuse me, ma'am.
Yes.
I have sent one question in the chat. Just not the exact procedure. I want to ask a concept about interpreting what to find. Can you view it?
This question is from graded assignment, right?
Yeah, yes, might be means I am not asking for the exact procedure. I just want to ask one concept. Means many questions are like this. Means here, as you can we can see it is mentioned that total students are 36, and we have to means award will be given to first 3 students who complete a task. So here we don't we cannot understand whether there will be any order or not. If we go by the multiplication principle, then we are falling under the permutation category. But since if we consider that there is no order, then it will be the combination part. So in this case, how to understand means what to do.
It is asking you about the class teacher rounds that the first 3 students.
Means
You
any
just
of the
have
three.
to.
Yes,
Yeah, it could be any of the 3.
yes. It could be any of the 3, but means if we go by the multiplication, then the order is coming. But if we consider that there is no order and apply the combination formula, then the result is different. Means
No, you are getting confused actually.
means how to understand whether we have to take order or not, and uh, how to understand whether choosing 3 out of 36 is the same as the multiplication principle what we do.
1 minute.
Means what we do in the multiplication principle means we assign 3 placeholders, and in the first place we tell that there is 36 ways, and since there is no repetition allowed, in the next there will be one less 35, and then in the same way 36, 35, 34 product. But if we that is by the multiplication principle, is it the same as the number of choosing 3 students out of 36 with no order? That this part I'm getting confused, and both are giving different result. Ma'am, your voice is not audible. Hello. Ma'am, are you speaking? Ma'am, am I audible?
Hello.
Hello. Your voice is not coming.
Hello.
Yes, sir. Now, yes.
Yeah, just a minute.
Ma'am, could you give your mail ID once, because in such a short time I'm trying to tell, I am not able to post it clearly. Means if you give your mail ID, then I can means several queries I have. Yeah, this will clear many other questions concepts. So could you please give your mail ID? Any mail ID that I can just post my
You
query,
can
because
you can put the queries on the discourse.
ma'am, I am not on the discourse. Means I have written the mail to support team. No reply came. How to join the discourse?
Okay, so you can ask your doubts in the next session.
I mean, actually, the problem is that in doubt session also means in such a short time, within 1 minute, I have to just say the query. But it is not actually a short query. It means 4 or 5 queries from this question, conceptual, and this question. And if these are clear, then many questions will be cleared. So I want to ask it very clearly, since this is such an intricate topic. So just any mail or any contact medium by which I can
Okay, 1 minute.
post. You can also understand, means in such a short time I am trying to convey, but it is not getting clearly put up.
Okay, I have sent my mail ID.
Means can I send the doubt in this mail ID with the picture and from my official mail ID?
See, it's better if you ask your question in the session itself.
Okay.
But if you have one thing, then I can see. Otherwise, you can put it on the discourse.
Means in the previous stats topics also it was okay that doubt means a specific thing, but here 4 or 5 concepts are together. Means if this is not clear, many questions will not be clear. So okay, ma'am, thank you, ma'am, for the mail idea. If I can mail it, would be helpful.
Okay, fine.
Thank you, ma'am.
Excuse me, ma'am. Could you please let us know if there will be a final revision class for quiz 1?
Yes, so I think one revision class has already happened for week 1 and 2. For week 3 and 4, it will also happen.
Okay, ma'am. Will be. Oh, thank you, ma'am. Okay.
Yeah, so it will be informed to you. You will receive a mail regarding that when it will happen. Just check your mails.
Okay, thank you, ma'am.
Okay, thank you, everyone.
Thank you, ma'am. Bye.
Yeah,
Good night,
I will
ma'am.
take the other. I will take other doubts in the next session.
Okay, ma'am.